For 30 years, a ghost in the machine haunted NASA. A tiny, persistent force that was pulling our farthest-flung spacecraft back towards the sun. So what was it? Was it just some simple engineering glitch, or did two lonely probes accidentally stumble upon the very fabric of space-time itself? Let's get into it.
Everything revolves around this number, an unbelievably small but constant acceleration. To put it in perspective, it's about the same force you'd feel from the gravity of a single grain of sand a mile away. But here's the thing, it was always there and it was always pointed directly back at the sun.
For decades, this phantom pull just shouldn't have existed. It flew in the face of everything we understood about gravity, and it sent scientists down this incredible rabbit hole of exotic theories. People started whispering about, brand new physics.
Okay, so to really get what a puzzle this was, we've got to go back to the beginning. Back to the Pioneer 10 and 11 spacecraft as they began their incredible journey into the unknown.
You see, this wasn't something they noticed right away. Pioneer 10 launched way back in '72, but it wasn't until 1980 when the craft was deep into space that the navigators started noticing something was off. And then it took another 18 years of painstaking analysis before they were sure enough to actually publish the measurement of this bizarre sunward pull. And here is the absolute heart of the mystery. Basic physics tells us that gravity gets weaker the farther you get from something. Simple, right? But that is not what Pioneer felt. From 20 astronomical units out to 70, we're talking billions of miles. This weird force stayed stubbornly constant. That just doesn't happen. It completely broke the rule.
So for years, this was a huge mystery. But then, around 2012, it seemed like the case was finally closed. The answer, it turned out, wasn't some new exotic physics, but something much simpler, the spacecraft itself.
The explanation is actually pretty clever. The spacecraft got its power from a plutonium core, right? And that thing generated a lot of heat. Well, because of the way Pioneer was built, more of that heat was radiating out the front of the craft. And since photons, particles of light and heat, actually have momentum, all that escaping heat was creating a tiny, constant push backward. Think of it like an incredibly weak but always-on little rocket engine.
And when they ran the numbers, it seemed to fit almost perfectly. This thermal recoil, as they called it, could account for about 80 to 90% of the weird force they were seeing. So you'd think, okay, problem solved. A simple engineering explanation for a deep space mystery. Well, not so fast. What about that leftover 10 to 20%?
And that's not all. When you really start digging into it, the whole thermal case starts to look a little shaky. Besides that nagging leftover force, the data showed the anomaly just kind of kicked in suddenly. A thermal effect should have been there from the very start. And maybe the weirdest part? The force stayed constant for decades, even as the plutonium core was getting weaker and putting out less heat over time.
And this, folks, is where things get really interesting. What if the anomaly isn't coming from the spacecraft at all? What if it's coming from the very fabric of space-time it's traveling through? It's a pretty wild idea, but just hear me out.
The concept is called geometric drag. And maybe the best way to wrap your head around it is to imagine you're in a boat. If you're moving through water and suddenly the water's density changes, say it gets thicker, you're going to feel a change in resistance, right? A drag. Well, this theory suggests that space-time itself has properties that can change, and moving through that change creates a similar force.
So the core idea here is that space-time isn't just empty and uniform. It actually has a property, this theory calls it a temperature, that changes based on the gravity around it. So as Pioneer was moving away from the sun and through this changing temperature gradient of space-time, it was experiencing this tiny constant drag. The anomaly wasn't a push, it was friction with reality itself.
All right, so we've got two very different ideas on the table. One says it's just heat coming off the machine. The other says it's a drag force from the geometry of space-time. How on earth could we tell the difference?
Well, this is what's so cool about science, right? The two theories actually make different and totally testable predictions. For example, the thermal force shouldn't care how fast the spacecraft is going, but this new geometric drag idea says the force should be proportional to its velocity. The thermal force depends on the spacecraft's specific shape and mass, while geometric drag should affect everything the same regardless of mass. This gives us a clear way to figure out who's right. And this isn't just some old, dusty mystery, it's a live question. We have other probes out there like New Horizons that have a completely different design and are now way out in the outer solar system. By tracking their motion with incredible precision, we could finally have the data we need to distinguish between a simple thermal push and this incredible geometric drag.
So let's pull back for a second. Why does any of this matter? Well, because if this geometric drag theory has it right, the implications are,
they're absolutely profound.
At the end of the day, we're left with this massive question. Was the Pioneer anomaly just a boring case of a warm spacecraft pushing itself around? Or did these simple probes, humanity's first messengers to the stars, accidentally detect a deep and totally unknown property of our universe?
I mean, what's really at stake here is our entire picture of reality. Einstein taught us that mass curves spacetime, and that's what gravity is. But this geometric theory suggests there's another layer to it, a kind of texture or a temperature to spacetime itself. The Pioneer anomaly could be the very first clue to that deeper structure.
And that just leaves us with this incredible final thought. These two spacecraft, they're silent now, just drifting out towards the stars. But they might have done so much more than just visit Jupiter and Saturn. In their tiny, weird deceleration, they might have recorded a whisper from the cosmos, a hint that they had detected the geometric structure of reality itself, a ghost in the machine that could change everything.